Dear children, praise the Lord and give thanks to the Lord always for keeping us good. God is always good to us and giving us everything what we need, not what we want, what we need are given by the God on the correct time. Those who are having the grace of the God. To get the grace of the God, have the fear of the God. Welcome to the Max class, children. How are you all? Hope that you have done your 5th cyclic test well. We are learning matrices so far. Before entering into today's class, let's recall what we learned in the previous classes. So the previous class we learned matrix multiplication. What's the condition for multiplication of two matrices? The first matrix column should be equal to second matrix rows. That is, number of columns in the first matrix should be equal to number of rows in the second matrix. Using that, we learned how to multiply 2 or 3 matrices. Then we learned properties of matrix multiplication. The first property is matrix multiplication is not commutative in general. That is, AB is not equal to BA. But in some of the cases, very rarely, AB is equal to BA. What we learned, we are going to learn in example 3.69. But matrix multiplication is distributive over matrix addition. That is, A of B plus C is equal to AB plus AC, or A plus B of C is equal to AC plus BC. Two distributive property, right distributive property and left distributive property we learn. Matrix multiplication is not commutative, but matrix multiplication is always associative. That is, AB is not equal to BA, but AB into C is always equal to A into BC. And last one, matrix multiplication by a unit matrix, that is A into I is equal to I into A, which is equal to A, where this I stands for identity matrix of any order which is equal to the given matrix A. These things we learned in the previous class, and we have learned we have solved some of the sums from exercise 3.19 also. Hope that you have done the homework. This class also we are going to continue the same sums leading to using the properties. Shall we enter the class, children? Yes. Look at example 3.73. A and B, two matrices are given. We are asked to verify AB the whole transpose is equal to B transpose into A transpose. Let us do the sum. What is given? Matrix A and matrix B are given. What's the order of matrix A here? 2 by 3 order. It has 2 rows and 3 columns. And matrix B, what's the order of matrix B? 3 by 2. 3 rows and 2 columns. So AB is possible because it has 3 columns, it has 3 rows. So AB is possible. Then you are asked to prove AB transpose is equal to B transpose into A transpose. So how do you first you have to find what is left hand side. Left hand side we have to calculate transpose of AB. First we have to calculate what is AB. A into B. Matrix A into B. Already I told you that AB is possible because it has 3 columns and this has 3 rows. Therefore AB is possible. What's the order of AB? 2 by 2 order, because 2 rows and 2 columns. That will come as the order of AB. So first row into first column. 1 into 2, 2. 2 into minus 1 is minus 2. And 1 into 0, 0. First row, first column over. Then first row, second column. 1 into minus 1, minus 1. 2 into 4, 8. 1 into 2 is 2. First row, second column is over. Then second row, first column. 2 into 2, 4. Minus 1 into minus 1 is plus 1. 1 into 0 is 0. So second row, first column over. Now second row, second column. 2 into minus 1 is minus 2. Minus 1 into 4 is minus 4. 1 into 2 is 2. Second row, second column also over. Now we have to sum up this to get what is AB. So AB is equal to 2 minus 2 will be cancelled, 0. So the first row, first column is 0. Then 8 plus 2, 10. 10 minus 1 is 9. That's the first row, second column. Then 4 plus 1, 5. That is second row, first column. And second row, second column, minus 2 plus 2 will be cancelled, then minus 4. We get what is AB. How do you get transpose of AB? Transpose of a matrix should be got by interchanging the rows and columns. So write the row as column. 0, 9 is the row. In transpose, we change into column. And second row will change into second column. So we got what is transpose of AB. So the first derivation is transpose of AB. Now take the right hand side. In right hand side we have to calculate what is transpose of B into transpose of A. What is B transpose? Just interchange the rows and columns of B to get transpose of B. That is, first column should be written as first row and second column should be written as second row. This is B transpose. And A transpose, just interchange the columns of A into row. 1, 2, the first column becomes first row, the second column 2 minus 1 becomes second row, and the third column 1, 1 becomes the third row. So this is the transpose of A. Let's calculate what is B transpose into A transpose. Look at RHS, B transpose into A transpose, B transpose into A transpose. First row, first column, 2 into 2, 2 minus 1 into 2 is minus 2, 0 into 1 is 0. Then first row into second column, 2 into 2, 4, minus 1 into minus 1 is plus 1, 0 into 1 is 0. Second row, first column, minus 1 into 1, 4 into 2, 8, 2 into 1, 2. Then second row, second column, minus 1 into 2, minus 2, 4 into minus 1 is minus 4, 2 into 1 is 2. Then simplify it to get what is B transpose into A transpose. 2 minus 2 will be cancelled, 0, 4 plus 1 is 5, then 8 plus 2, 10, 10 minus 1 is 9, minus 2 plus 2 will be cancelled, then it is minus 4. The second derivation is B transpose into A transpose. Compare 1 and 2 derivations, we get AB the whole transpose is equal to B transpose into A transpose. Hence it is proved. Look at example 3.69. Two matrices A and B are given. We are asked to show A and B satisfy commutative property with respect to matrix multiplication. Commutative property is a word used for two matrices. Commutative property under matrix multiplication is AB is equal to BA. Shall we prove that? What is given? A and B, two matrices are given. And what you have to prove? Commutative property under matrix multiplication, that is AB is equal to BA. Then under proof, first we have to calculate left hand side AB, A into B. Very easy to do this, children. Just to be careful in multiplying the square root numbers. Very simple. In all the square root, it consists of root 2 only. What's the answer for root 2 into root 2? It is equal to root 4. Finally, it comes as 2. So root 2 into root 2 is equal to 2. Root 3 into root 3 is equal to 3. Root 5 into root 5 is equal to 5. That you all know that. Okay. Let us do the sum. This is of order 2 by 2. 2 rows, 2 columns. This is also of order 2 by 2. So the resulting matrix AB is also of order 2 by 2. Multiply first row by first column. 2 into 2. 2 to the 4. Then minus 2 root 2 into minus root 2. Multiply root 2 into root 2, which is equal to 2. Then minus 2 into minus 2 is equal to plus 4. So 4 plus 4 is the first row, first column element. Then first row, second column. 2 into 2 root 2. Multiply only these numbers. 2 into 2, 4. That is 4 root 2. Then these two elements. First row, second column elements. 2 into root 2 is 4 root 2. Then minus 2 into 2 into 2 is equal to minus 4 root 2. So 4 root 2 minus 4 root 2. That's the first row, second column element. Then second row, first column element. Root 2 into 2. That is equal to 2 root 2. Then root 2 into minus 2 root 2. That is equal to minus 2 root 2. So root 2 into 2, 2 root 2. 2 into minus root 2 is minus 2 root 2. Then second row, second column. Root 2 multiplied by 2 root 2. That is root 2 into root 2 is 2. Then 2 2s are 4. Therefore it is 4. Then second row, second column. That is so root 2 into root 2, that is equal to 4. Then again 2 into 2, that is also equal to 4. So we got the elements. AB is equal to 4 plus 4. 4 root 2 minus root 2. 2 root 2 minus 2 root 2. 4 plus 4. Then AB is equal to 8008. That's the first derivation. Then take RHS, which is equal to BA. B into A. Write B first, then A. First row into first column. 2 into 2, that is equal to 4. 2 root 2 into root 2 is root 2 into root 2 is 2. 2 into 2, 4. That is 4 plus 4. Then first row into second column. 2 into minus 2 root 2. That is minus 4 root 2. Then second first row into this. That is 2 into 2 root 2 is plus 4 root 2. 2 into minus 2 root 2 is minus 4 root 2. 2 root 2 into 2 is equal to plus 4 root 2. Then second row into first column. 2 into minus root 2 is minus 2 root 2. 2 into root 2 is equal to plus 2 root 2. Then second row, second column, minus root 2 into minus 2 root 2. Minus and minus will change into plus. Root 2 into root 2 is 2. Then 2 2s are 4. It is 4. Then 2 into 2 is also 4. Simplify this. This will be 0 and this also will be 0. 4 plus 4 8 and 4 plus 4 is 8. BA is also equal to 8 0 0 8. That is the second derivation. So from 1 and 2 we get AB is equal to BA. Hence this is proved. Look at example 3.70. It's an important sum, children. It's asked many times for 2 mark sums. What is given? Solve. A matrix multiplication is given with the 2 variables x and y. You are asked to find the value of what is x, what is y. Solve means you are asked to find the value of the unknowns given. When 2 matrices are multiplied, then the answer is this. The first matrix is 2 1 1 2. Second matrix is x y. When you multiply these 2 matrices, the answer is 4 5. And your solve means you are asked to find what's the value of x and what's the value of y. Look at its order. It's of 2 by 2 order, 2 row, 2 columns. And it's of order 2 by 1, 2 rows and 1 column. So product is in the order 2 by 1. This 2 and this 2 will be cancelled. And the product of these 2 matrices will be in the order 2 by 1. Multiply this. First row, first column. 2 into x, 2x. 1 into y plus y. So first row, first column element is 2x plus y. This is a single element. Then second row, first column. 1 into x, x plus 2 into y plus 2y. X plus 2y is the second row, first column element. So this is the product of these 2 matrices, which is of order 2 by 1. Which is equal to 4 by 1. This is also of order 2 by 1. Here these 2 matrices are having the same order and it is given that they are equal. Therefore, these 2 matrices are equal. If 2 matrices are equal, surely their corresponding elements are same. So, the first row, first column element 2x plus y is equal to 4. That's the first equation. Then second row, first column element x plus 2y is equal to 5. This is the second equation. So, from the product of these 2 matrices and also equating the product with the given answer, we get 2 equations. Then you know how to solve this equation. Very simple equations, linear equations in 2 variables. How do you solve this? By using the elimination method. You have to eliminate either x or y. I have decided to eliminate x. Here 2x, here simply x. So what we have to do? The second equation should be multiplied by 2. Write the first equation as it is. Second equation should be multiplied by 2. All these 3 elements should be multiplied by 2. 2 into x, 2x. 2 into 2y, 4y, 5 into 2, 10. So 2x plus 4y is equal to 10. Then they are of same sign. We have decided to eliminate x, but both are 2x. So we have to change the sign of this. All the elements should be changed in sign. So change minus 2x, minus 4y, minus 10. This 2x minus 2x will be eliminated. Then 4 minus 4 plus y is equal to minus 3y. Minus 10 plus 4 is equal to minus 6. From this we got y is equal to 2. And then we substitute y is equal to 2 in equation 1. What is equation 1? 2x plus y is equal to 4. In the place of y, you substitute 2. So 2x plus 2 is equal to 4. 2x is equal to, take this plus 2 there, it is minus 2. 2x is equal to 2. So x is equal to 2 by 2. We get x is equal to 1. Finally, by solving this given equation, we got the value of x and y. What is x? X is equal to 1 and y is equal to 2. Look at exercise 3.19. Some sums we have to do. Look at third sum. A has A rows and A plus 3 columns. Here the capital A represents a matrix. And how many rows it has? A rows and how many columns? A plus 3 columns. And B has B rows and 17 minus B columns. That is matrix B has B rows and 17 minus B columns. If both products AB and BA exist, then find what is A and what's B. So order of matrix A and order of matrix B are given. Both consist of variables A and B. Order of matrix A is A by A plus 3. It has A rows and A plus 3 columns. And order of matrix B is B by 17 minus B. It has B rows and 17 minus B columns. And given that both AB and BA exist. From this, with this condition, we have to calculate what is A and what is B. Let us see, if AB exists, then columns in A is equal to rows in B. The condition for two matrices to be multiplied is, you know it thoroughly, the columns in the first matrix should be equal to the rows in the second matrix. Using that condition, if AB exists, then columns in A should be equal to rows in B. Equate that. What is columns in A? A plus 3, which is equal to, what's rows in B? Which is equal to B. So here we can derive one linear equation in two variables. Let us bring this B this side, that is minus B. A minus B is equal to, take this plus 3 that side, that is minus 3. So A minus B is equal to minus 3 is the first equation which we get from AB exists. Then if BA exists, BA is also possible. Then columns in B is equal to rows in A. What is columns in B? 17 minus B. What is rows in A? A. So therefore 17 minus B is equal to A. So take B minus B to that side, that is plus B. 17 is equal to A plus B. We usually write the variables on the LHS, so change it as A plus B is equal to 17. That is the second equation. So we get first and second equation, solve them, very simple equations which are having the one as variable coefficient. So directly we can eliminate minus B and plus B. Solving these two, 2A is equal to 14, therefore A is equal to 7. Substitute A is equal to 7 in the first equation. We get what is B? Minus B is equal to minus 10. Then answer for B is 10. Finally we got the answer. A is equal to 7 and B is equal to 10. Children, it's very important in matrix to find the square of a matrix. Find the square of a matrix is an important task. Listen that if A is given, what is A square? Most of the time you write just squaring the elements of A. Most of the children, A is equal to 4 minus 1, 5, 2 means they may write it as 16, 1, 25, 4. Directly squaring the given elements. That is very wrong. Completely wrong. So very important, note it down. Finding square of a matrix. If A is given, then A square is equal to A into A. By proper multiplication, you have to multiply A by A. Not directly squaring each element of A. That is completely wrong. So keep it in mind. Multiply A by A. Then first row, first column, first row, second column, second row, first column, second row, second column. Like the same proper multiplication method, you have to multiply them. Final answer of A square is 11 minus 6, 30 minus 1. If you directly multiply, square it, what will be the answer? 16, 1, 25, 4. That is wrong. So finding square of a matrix is very important. In 5 mark sums it will come. If you just square it and write, then the whole sum will be wrong. So keep it in mind. To find the square of a matrix, we have to multiply the matrix by itself, and proper method should be used to find the square of a given matrix. Look at the 8th question. A and B, two matrices are given. We are asked to prove A square plus B square is equal to I. But here the matrices are given with trigonometric terms. Thetas, cos theta, sin theta. Don't be afraid, children. It's easy to deal with that. Okay. And what does I stands for? I stands for unit matrix. That is, unit matrix means it has 1 in the leading diagonal. Okay. So what is A? A is cos theta 0, 0 cos theta, and B is equal to, how do you read this? Sin theta. Some of you are read the sin theta. That's wrong. Okay, sin theta 0, 0 sin theta. Two matrices are given. You are asked to prove A square plus B square is equal to I. Let's find what is A square. A square is A is equal to cos theta 0, 0 cos theta. How do you get A square? Multiplying A by A. Okay. Cos theta 0, 0 cos theta multiplied by cos theta 0, 0 cos theta. First row, first column. Cos theta into cos theta. Cos square theta. Then 0 into 0 is plus 0. First row, first column is over. Then first row, second column. Cos theta into 0, 0. 0 into cos theta is also 0. Then second row, first column. 0 plus cos theta 0. Cos theta into 0 is 0. Second row, second column. 0 into 0 is 0. Cos theta into cos theta is plus cos square theta. So finally we get a square is equal to cos square theta 0, 0 cos square theta. You may think that man, directly if you square that the same answer will come back. For this sum it will come, but that's not a correct method of doing. Okay. So if you want to find a square, you have to multiply a by proper row by column multiplication method. Then b is equal to sin theta 0, 0 sin theta. How do you get b square? Multiply b by proper multiplication method. First row, first column. Sin theta into sin theta is sin square theta. 0 into 0 is plus 0. So first row, first column over. Then first row, second column. Sin theta into 0, 0. 0 into sin theta, 0. Then second row, first column, 0 into sin theta, 0. Sin theta into 0 is also 0. Then second row, second column, 0 into 0, 0. Sin theta into sin theta is sin square theta. So finally we get b square is equal to sin square theta, 0, 0, sin square theta. What we have to prove? A square plus b square is equal to I. Let's find what is a square plus b square. Addition is very simple. Just you have to add the corresponding entries. First row, first column, cos square. There, first row, first column is sin square. Cos square theta plus sin square theta is equal to 1. This is the new identity you are going to learn in the chapter trigonometry. But now you just note it down. Cos square theta plus sin square theta is equal to 1. Therefore, cos square theta plus sin square theta is equal to 1. 0 plus 0 is 0. Here also 0 plus 0 is 0. Here again cos square theta plus sin square theta is equal to 1. This is a square matrix. In the leading diagonal it has 1. Therefore, this is equal to I, unit matrix. So, a square plus b square is equal to I. What we have proved from the given information. Look at sum number 11. Two matrices A and I are given. A is equal to AB, CD. And I, you know that what is identity matrix? 1, 0, 0, 1. Identity matrix of order 2. And you have to prove that A square minus A plus D of A is equal to B minus C, BC minus AD of I. A square minus A plus D of A is equal to BC minus AD of I. It's very easy to do, but you have to do with carefulness. Okay, this is the proof. First we have to calculate LHS. In LHS, what is that? A square minus A plus D of A. First let us find what is A square. A is equal to ABCD. A square means, don't square it as it is. What we have to do? Multiply A by A. So ABCD into ABCD. First row, first column. A into A square. B plus B into C plus BC. Then first row, second column. A into B, AB plus B into D, BD. First row, first column, first row, second column are over. Now come to second row, first column. C into A, AC plus D into C, CD. Second row, second column. C into B, BC plus D into D is B square. So now we got the value of A square is equal to A square plus BC, AB plus BD, AC plus CD, BC plus D square. Children, see how differently it comes. If you directly square it up, what will be there? A square, B square, C square, D square, then it will be completely wrong. So, correctly find the square of given matrix by multiplying it by itself. Next, what is this A plus D into A? This A plus D should be considered as a scalar. Scalar means any number, 3 or 4 or 5 or 6 or any number. How do you get 3A? Multiplying all the elements of A by the 3. How do you get 5A? Multiplying all the elements of A by 5. By the same, how do you get A plus D of A? Multiply all the elements of A by A plus D. Okay, so A plus D of A is equal to A plus D into ABCD. So all these 4 elements should be multiplied by A plus D. So for your clearance, I have written like this: A plus D into A plus D into B, A plus D into C, A plus D into D. Multiply A plus D by A into A square plus AD. Then A plus D into B is AB plus BD. A plus D into C is AC plus CD. A plus D into D is AD plus D square. Now we get what is A plus D of A. A plus D is a scalar. We have to multiply all the elements of A by A plus D. We got this answer as A plus D of A. Then what we have to do? A square minus A plus D of A. A square minus A plus D of A is equal to, write down A square values minus A plus D of A values. Let us apply that. A square minus A plus D of A. Subtract this corresponding entries. A square plus BC minus A square plus AD. So these two should be changed in sign. Minus A minus AB. Like the same, AB plus BD minus AB plus BD minus AB minus BD. They should be changed in their sign. And AC plus CD minus AC minus CD. BC plus D square minus AD minus D square. Okay, when we simplify them, here A square minus A square will be cancelled, then BC minus AD. Here all these terms will be cancelled, 0. Here also AC minus AC, CD minus CD will be cancelled. Here D square minus D square will be cancelled, BC minus AD. So finally we got the answer for A square minus A plus D of A is equal to this, where RHS BC minus AD into I. BC minus AD should be taken as a scalar, a single number, multiplied by 1001. So 1 into BC minus AD is BC minus AD. 0 into BC minus AD is 0. Again 0 into BC minus AD is 0. 1 into BC minus AD is BC minus AD, second derivation. Comparing the first and second derivation, we get A square minus A plus D of A is equal to BC minus AD into I, which is proved. Children, this class we have seen examples 3.73, 3.70 and 3.69 and some of the sums from exercise 3.19, which are all based on the properties of matrix multiplication. And the important thing you have to keep it in mind is how to find the square of a matrix. When matrix A is given, how do you get A square? Should not square the elements directly. You have to multiply the matrix by itself. That is, A square is equal to A into A by proper method of multiplication, row by column order. Okay. And one more thing is, trigonometric identity, you have to keep it in mind is cos square theta plus sin square theta is equal to 1. Listen the class carefully, children, and do the sums which are given in the homework page. Students, the roots of education are bitter, but the fruit is always sweeter. So don't hesitate to learn at this stage. Love learning and have a sweet future. Thank you, children. Wish you all success in your life. God bless you, dear children. Bye.